This video is the tutorial for the Pallant chapter 19 for 2A between groups analysis variance, aka a factorial ANOVA. When you look at the homework sheet for chapter 19, what you'll see is I'm asking you to run an example of a 2A ANOVA, and I also want you to get some practice writing up a results paragraph. So I will be drawing your attention, as I usually do, to where you find an example of how to do that in your Pallant textbook, and I'll kind of talk you through what I want. It may be difficult using the quiz context for this process. I'm going to ask you to give it a try. If you find it frustrating and irritating and you would prefer to write out your paragraph and your table in a Word document, feel free to do that. Just let me know to look for it. You can turn it in the same Dropbox where you turn in your SPSS output. All right, the instructions for doing the 2A ANOVA, the 2A between groups ANOVA, the instructions are on page 283 in your Pallant text. And we're using the survey.save database. We start where we usually start, which is at Analyze. And this time we're going to go to what's called a general linear model. And we're going to choose the first option for univariate. And what you see is a pretty busy dialog box. The next step, you're going to choose, and I've asked you to look at perceived stress as your dependent variable, and the impact of both sex and age in 5 groups on perceived stress. And what we want to find out is, do those two variables, those two categorical variables, sex and age, do they interact? Do they have independent influence on perceived stress? So first, your instructions say to choose your dependent variable. So we need to scroll all the way down to our calculated variables and select perceived stress, put that in the dependent box. Then the instructions say to select your two independent variables, which are both categorical variables. So first we want sex. We're going to put that in the fixed factor box. And then we need to go down to the bottom where we have age that's been recategorized into 5 groups. And we put that into fixed factors as well. Then we go to the options button, and we want to select descriptive statistics because you need the means, standard deviations, and ends for each group in the analysis. We want the estimates of effect sizes, and we want the homogeneity tests. That will tell us whether we violated some key assumptions. Then we click continue. Then we select the post hoc button, and your instructions say that you should choose all the independent variables you're interested in, but in parentheses it says this variable should have 3 or more levels. So sex only has 2 levels, so we don't need post hoc tests for that. There's only 2 groups to compare, but we do need post hoc groups for the 5 age groups. Because basically we want to look at them by pairs, like youngest versus the next oldest, and so on. And we're going to use the Tukey test. It's actually the Tukey HSD, or honestly significant difference, which I've always thought was super funny. Then we click continue. Then we select plots. Here's another busy dialog box. In the horizontal axis box, you want to put the IV that has the most groups. So that would be age in 5 groups. And then in the box that says separate lines, you want to put sex. And then you click add. And what this will give us is a line chart that will plot out 1 line for sex, for males, and 1 line for females, and you'll also see for males and females in each age group on that plot. And we're ready to go. So we click continue and we click OK. Now this is our output, and you should go to pages 286, 287, 288 in your textbook and follow along the recommended interpretation of the findings. So what you see first are the N, the number of subjects in each of your groups. So you have the number of males, the number of females, and the number of people in each of the age groups. Then we want to look at how those groups lay out when you separate them by males and females. So in this next box you have for males, the mean, the standard deviation, and the N for each of the 5 age groups, and then the same thing again for females. You have the number, the mean, the standard deviation, and the N for each of the 5 age groups, plus the total for those groups. And then at the bottom of the table you have the total values regardless of sex. So these would just be the age values, the mean, standard deviation, and N for each of those. Now the next part of the output is Levine's test of equality of error variances. And what we want to look for here, as Pallant says, you want this to be greater than 0.05. So you want this test to be non-significant. And that is the case. So what that means is that we haven't violated an assumption that the error variances across the groups is equal. And that means we can go ahead and interpret our test. Now the between groups differences, that's the real meat of our two-way ANOVA test, and the significance tests are going to be presented in this tests of between subjects effect table. And this one can be super confusing. One of the biggest mistakes my students make is thinking that this column where it says partially eta squared is actually the significance or the p-value, when the column that you want to pay attention to first is the sig column. That's your p-value, your significance value for this particular test. The columns that you're given degrees of freedom, mean square, the F value, and the significance value. Then you're also given your effect size measure. Now, as Pallant says, and I've often wondered, why is the table set up this way if you're supposed to start in the middle of it? The first thing you want to look at is the interaction effect, because if there's a significant interaction, then it's much more challenging to interpret the main effects, which are the independent effects of our two independent variables. So first we want to determine, is there a significant interaction between sex and age? So in other words, if we want to understand the impact of the age groups on perceived stress, does it depend on whether you're male or female? And that's essentially the question you're asking. So we look at the significance value for the interaction, and we can state that this is a non-significant interaction effect. So that means we can go ahead and interpret the mean effects directly. So we start with sex, and we go over the significance value is, the p-value is 0.004. So there is a significant mean effect for sex. One row down, there's also a significant effect for age. So the three test results that we see here, first, there's a non-significant interaction. Second, there is a significant mean effect for age. There's also a significant mean effect for sex. Then you want to look at the effect size. So here you're given the partial eta squared values. And we're only looking at the effect for sex and the effect for age in 5 groups. And what you see is a partial eta squared of 0.02 and a partial eta squared of 0.035. Both of those are relatively small effect sizes. Now you need to, the next step is kind of, so what does this mean? If I have main effects for sex and age, what does that really mean? So I go back up here and I think about overall the effect for age. Who appears to be experiencing the lower level of perceived stress versus the higher level of perceived stress? If you take this overall value for males, so regardless of age, the level for males is, if you round up, 26. If you go, again, regardless of age, and you look at the mean value for females, it's about 27. So females appear to be reporting slightly higher perceived stress than males overall. And it's a statistically significant effect, but the effect size is small. So when you think about this, how meaningful is the difference between 26 and 27? So you should always kind of think hard about what does a significant test result mean in a practical sense. For age, when we look at these means, we do have a significant main effect for age, meaning somewhere in this pack of 5 means, there's a significant difference. And we'll need to look at the post-hoc test before we can determine where that difference is. But right away, we can kind of take a peek at the pattern. The highest mean is with the youngest group. Then you have some middle values here in the middle age groups. The lowest values are for the 25 to 32-year-olds and the 50-plus group. So we jump down to the multiple comparisons table. Super busy table. Some journals are starting to ask for confidence interval information to be presented. Other journals do not. It really just depends on the culture of that particular journal. We're going to focus on where we have, and the way these tables are set up, you're given every possible comparison to look at. And this is regardless of gender. So sex is out of the picture. This is just the paired comparisons looking at age. So the first block, we have the 18 to 24-year-olds being compared with every other group. The second block, the 25 to 32-year-olds being compared with every other group. The 33 to 40-year-olds, and so on. The sign of the mean difference, it depends on which mean in the comparison is higher. So the test is going to ask, are they significantly different from one another? So the significant differences are going to be marked by an asterisk. So this first column here, the mean difference, that asterisk suggests that there is a significant test result. And if you go over to the significance column, you'll see the p-value listed for you. Now notice here, I've got this pair, 18 to 24 versus 25 to 32. Got the same thing down here, 25 to 32 versus 18 to 24. Notice that the mean difference value up here is 29.9 or 2.95, and down here it's a negative 2.95. So it's the same comparison, it's just that which mean is higher is reversed. So it's also exactly the same significance value. So regardless of which direction you point it, 18 to 24 versus 25 to 32, or 25 to 32 versus 18 to 24, it's significant. You don't have to report them separately. It's essentially the same test. Then when we look at the 50 plus group versus the 18 to 24 group, that is also significant. Now if you want to see where that reflexive result is in the table, 50 versus 18 to 24, you have the negative version and the same significance value. Now if we follow down the row here, and we're trying to identify where the other significant values are. Notice how you have some of the same numbers repeated. There are only two significant between groups differences hidden in this table. It looks like there are a total of 4, but there are only just, or 3. Is it 3 or is it 2? 1. So 4. I haven't had enough coffee yet, I guess. So it looks like there are 4, but there are really only 2, because 2 out of the 4 are actually just reversals. So essentially you've got differences between the youngest and the group directly next to it, and the youngest and the oldest groups of participants. And those are the 2 significant post hoc tests. Don't need that table. Now the plot, the means plot, gives you a way of visualizing in your mind the differences. So what you can see here, remember that an interaction effect, as Pallant describes it, an interaction effect is when you see typically non-parallel lines. Now essentially these lines are parallel. While there is a tendency toward the possibility of an interaction, the significance test for the interaction effect was non-significant. So you notice here that the green line, which is for females, is above the line for that of males. And you see this, both males and females are reporting the highest levels of stress when they're youngest. Both decrease over time, but males tend to steadily decrease, or at least sort of, whereas females tend to jump up during middle age again, and then slowly decline. So, the difference between the green line and the blue line is the main effect for sex. The peaks and valleys across age, that's the main effect for age. And remember how the significance tests worked. You had the youngest versus the oldest, that was significant, and the youngest versus the group next to it, the 25 to 32s. So that's the main effect for age. Now, in your, what I want you to put in the quiz section, the homework sheet here, I ask you to interpret the results. Is there a significant interaction effect? Are the 2 main effects significant? So you can respond to that pretty easily in the quiz format. Where it's going to be a little more challenging is writing up the paragraph. And I have been asking that you show me that you have learned by reading in your Pallant text how to present the data for me. Now on page 288 in your text there's a gray box, and it shows how to present the results of a two-way between group ANOVA. And what I want you to learn to show me is that you know how to do this. Now you can, as I said, if this gets to be too irritating, what you can write in the quiz space is, I'm turning in a Word document, and then I will look at the Word document and assign a score based on what I see in that Word document. If you find it easy to go ahead and type your paragraph in the quiz space, then that's fine too. I did put in the homework sheet, report the means and standard deviations for each group in a table. You can either build a table, or you can follow the example in your Pallant text on page 288, where she actually reports the means and standard deviations in the paragraph itself. Remember, you don't need to do both. You can do one or the other. Regardless, it may be easier whether you turn in the Word document or not. It will definitely be easier to write it in a Word document and then copy and paste it into your quiz space. So whatever's easier for you. I've very much struggled with how to use this quiz format for homework. I'm not trying to make your life difficult, so I want you to understand that there's some flexibility with homework 19. Okay, that concludes my tutorial for chapter 19.